So, let's go. Right now, a comet is diving toward the sun. If it survives, it becomes the brightest thing in the night sky this month. If it doesn't, it could trigger a global blackout across the globe. That's just the first thing on this list. Some of these you'll see with your naked eyes in the next 3 years. Some are already happening and nobody told you, and one of them involves the slow, quiet death of humanity's most distant creation. Here are 10 terrifying space events you will witness before you die. Number 10. The comet that might be burning right now. There's a comet called MAPS hurtling toward the sun as you watch this. It was discovered in January 2026 by a team using robotic telescopes in Chile, and on April 4th, it makes its closest pass. How close? 0.0057 astronomical units. That's so close to the sun that most objects at that distance just stop existing. MAPS is a Kreutz sungrazer. That means it's a fragment of one massive ancient comet that broke apart about 1,000 years ago. Most of those fragments are tiny. They hit the sun's neighborhood and quietly disintegrate. But some survive. In 1965, a sungrazer called Ikea Seki made it through and became so bright you could see it during the day. Magnitude -10. Brighter than anything in the night sky by a ridiculous margin. If MAPS survives, it's predicted to hit magnitude -8. Brighter than Venus. Possibly visible in daylight with a dust tail stretching millions of kilometers. If it doesn't survive, you get nothing. It just vanishes into the solar glare like it was never there. And here's the thing, its orbital period is about 1900 years. Last time this comet was anywhere near the sun, the Roman Empire was still a going concern. There's also another comet, Pan-STARRS, potentially hitting naked eye brightness late April. If both deliver, you could get 2 comets visible without a telescope in a single month. That almost never happens. But nobody knows yet. That's the part that matters. Right now, it's falling and we're all just watching. Number 9. A star is about to explode and it's 80 years overdue. 3,000 light years away, there's a binary star system called T Coronae Borealis. Most people call it the Blaze Star. It's a white dwarf orbiting with a red giant, and the white dwarf is stealing hydrogen from its companion, slowly, steadily, piling fuel onto its own surface. And every 80 years or so, enough accumulates to trigger a thermonuclear explosion. The white dwarf survives, resets, starts stealing again. The last time it went off was 1946. A 15-year-old Welsh schoolboy named Michael Woodman spotted the brightening, wrote a letter to the Astronomer Royal, and helped establish the 80-year cycle. The eruption before that was 1866. Before that, possibly 1217, when a German abbot wrote about a faint star that for a time shone with great light. So it's overdue, and the signs are there. The star started dimming in March 2023, which is exactly what it did before the 1946 eruption. An astronomer at the Paris Observatory calculated specific dates based on the system's orbital mechanics. March 2025. Passed. November 2025. Passed. The next windows are June 2026 and February 2027. When it finally goes, it'll jump from magnitude 10, completely invisible to your eyes, to magnitude 2. As bright as Polaris. A new star appearing in the northern crown for a few days, then fading back to nothing for another 80 years. One of only 10 recurrent novae in the entire Milky Way with a cycle under a century. And the light you'll see already left 3,000 years ago. Whatever happens next, it already happened during the Bronze Age. We're just waiting for the news to arrive. Number 8. The God of Chaos is coming on a Friday the 13th. On April 13th, 2029, an asteroid named after the Egyptian god of destruction will pass closer to Earth than your television satellites. Apophis. 450 meters long, roughly the height of the Eiffel Tower, peanut-shaped, made of rock and metal, and it's going to come within 31,600 kilometers of Earth's surface. That's inside the ring where geostationary satellites orbit. 1/10 the distance to the moon, the closest flyby of an asteroid this size in all of recorded human history. On a Friday the 13th, when it was discovered in 2004, initial calculations gave it a 2.7% chance of hitting Earth. That's the highest threat rating ever assigned to an asteroid on the Torino scale, level 4. The astronomers who named it picked Apophis partly because of the Egyptian mythology, partly because of a villain in Stargate SG-1. The discoverer confirmed that. Later observations ruled out any impact for at least the next 100 years. The uncertainty in its 2029 position is now plus or minus 3.3 kilometers. We know exactly where it'll be, and it'll be right there. Here's what you'll actually see. Apophis will reach magnitude 3.1, visible to the naked eye, and it'll be moving at 42 degrees per hour. That means it crosses a full moon width every minute. You will watch it move against the stars in real time. You have never seen an asteroid do that. Nobody alive has. About 2 billion people across Europe, Africa, and Western Asia will be able to see it. An MIT professor said that's 4 times more people than watched Neil Armstrong walk on the moon. And while you're watching, Earth's gravity will be squeezing the asteroid. Tidal forces stretching it, possibly triggering quakes on its surface, reshuffling its rubble. Its orbit will permanently change. It'll enter the flyby as one type of asteroid and leave as another. 3 spacecraft are converging to watch. NASA's OSIRIS-APEX, already en route. ESA's Ramses. Japan's Destiny Plus. The United Nations declared 2029 the International Year of Asteroid Awareness. If it had hit, the impact would have released about 1,200 megatons of energy. 24 times the largest nuclear weapon ever detonated, but it won't hit. It'll just pass so close that for one night, the god of chaos becomes the most watched object in human history. And then it leaves, changed by us, and we, changed by it. Number 7. The sun going dark over the Valley of the Kings. Between 2026 and 2028, 3 total solar eclipses happen in under 2 years. That almost never happens. 3 separate eclipse families called Saros cycles are all firing in sequence, and they're hitting some of the most dramatic locations on Earth. August 12th, 2026. Totality sweeps over Iceland, the first and only total eclipse there in the entire 21st century, then crosses into Spain. August 2nd, 2027, the eclipse of the century. Totality over southern Spain, Tangier, across North Africa, through Luxor, Egypt, and on to Saudi Arabia. Maximum duration 6 minutes and 23 seconds of totality. The 2024 American eclipse lasted 4 minutes 28 seconds. This one blows it away. And it happens directly over the Valley of the Kings. July 22nd, 2028. Totality over Sydney and the Australian outback. Spain gets 3 major solar eclipses in 532 days. No other accessible place on Earth gets that. If you've never stood in totality, you don't know what it does to you. The temperature drops 5 degrees Celsius in minutes. Birds go silent, then start roosting like it's night. The horizon glows 360 degrees around you in sunset colors. Shadow bands ripple across the ground. And for those few minutes, you can look up and see the sun's corona with your naked eyes. Ghostly white tendrils stretching millions of kilometers into space, normally invisible, suddenly just there. The whole thing only works because of a cosmic coincidence. The sun is about 400 times the moon's diameter and about 400 times farther away. That ratio is unique in our solar system, and it's temporary. The moon is slowly drifting away. In about 600 million years, total eclipses stop happening forever. You're alive during the window. These 3 are your best chances to use it. Number 6. The storm that turns off civilization. On September 1st, 1859, a British astronomer named Richard Carrington watched a white light flare erupt from a sunspot the size of Jupiter. What hit Earth over the next week was the most powerful geomagnetic storm in recorded history. Telegraph operators saw sparks fly out of their equipment. Stations caught fire. And then something genuinely strange happened. Operators disconnected their batteries and found they could still send messages. The storm was generating current in the wires by itself. Auroras reached the Caribbean. People could read newspapers by their light at midnight. That was 1859. The most advanced electrical technology on Earth was the telegraph. Now picture it today. A Carrington-level event would hit in 3 phases. Phase 1. An X-class solar flare disrupts radar, GPS, and communications within 8 minutes. That's how long light takes to reach us. Phase 2. A storm of energetic particles fries satellite electronics. Phase 3, 18 to 36 hours later, The coronal mass ejection arrives, power grids overload, satellite drag increases by up to 400%, dragging them out of orbit. One study estimated $2.6 trillion in damage to the United States alone. Swiss Re, the reinsurance giant, estimates 10% of all grid transformers destroyed. Those transformers are custom built, cost millions each, and take 1 to 2 years to manufacture. Recovery from a worst-case scenario could take a decade. This isn't hypothetical. In July 2012, a Carrington-class eruption crossed Earth's orbital path 9 days after Earth had been in that exact spot. 9 days. That's how close the modern world came to going dark, and nobody even noticed until afterward. In May 2024, the strongest storm since 2003 hit. Auroras visible from Florida. Starlink satellites knocked out of orbit. GPS-guided farming equipment stopped working mid-planting season. That was a moderate event. And we're currently at solar maximum, the peak of the sun's 11-year activity cycle, when these things are most likely. We have an AI early warning system now. It gives about 30 minutes notice, but here's the problem. The severity depends on the storm's magnetic field orientation, and we can't measure that until it's about an hour away. So you get a warning, but you don't know how bad it is until it's basically already here. 20,000 planes are in the air at any given moment. Most of them depend on GPS. And one day, the sun will do what the sun does, and we'll find out exactly how ready we were. When that happens, the most terrifying part won't be the sky. It'll be the silence where your phone used to work. Number 5. The junkyard above your head. In 1978, a NASA scientist named Donald Kessler described a scenario that sounded like science fiction. If enough debris accumulates in orbit, collisions start creating more debris, which causes more collisions, which creates more debris. A chain reaction that turns entire orbital shells into impassable shrapnel fields. It's called the Kessler syndrome. Here's where we are right now. 1.2 million fragments larger than 1 centimeter, 140 million pieces larger than 1 millimeter. Over 11,800 active satellites, 7,135 of them Starlink alone. A group of researchers created something called the crash clock. It asks a simple question. If every satellite suddenly lost its ability to steer, how long before the first collision? In 2018, the answer was 164 days. In 2025, the answer is 5.5 days. That's not saying Kessler syndrome is 5 days away. It's saying that's how dependent we are on active collision avoidance every single second of every single day. Starlink satellites performed 144,404 avoidance maneuvers in the first half of 2025 alone. That's a collision warning every couple of minutes around the clock for 6 months. 1 gram of debris at 15 kilometers per second carries the kinetic energy of a 2-ton rhinoceros at full charge. A paint fleck at orbital velocity can pit a shuttle window. In November 2025, the Chinese Shenzhou 20 crew found cracks in their spacecraft viewport, debris suspected, and here's where this connects to the last section. A 2025 analysis found that a large solar storm could knock out satellites' ability to maneuver for long enough to start the cascade. Less than 3 days to act, the sun doesn't just threaten the ground, it threatens the sky too. 78% of commercial aviation depends on GPS. 5.56 billion internet users rely on satellite-dependent infrastructure. If a cascade starts, we don't lose the internet in a dramatic explosion. We lose it gradually, piece by piece, as orbit becomes unusable for generations. Solutions exist. A European mission is targeting 2026 for a first debris removal demonstration. Models say we'd need 5 to 10 large removals per year to stabilize the situation. The estimated cost, $500 million to $1 billion annually. The total number of satellites is projected to increase 6-fold by 2030. We're adding to the junkyard faster than we're learning to clean it. Number 4. The hole in Earth's shield. You probably think of Earth's magnetic field as this constant, reliable thing. An invisible bubble protecting you from the worst the sun throws at you. It's not constant. It's not even close. Over South America and the southern Atlantic Ocean, there's a region where Earth's magnetic field is abnormally weak. It's called the South Atlantic Anomaly, and it's getting worse. The European Space Agency has 3 satellites called Swarm that have been monitoring the field since 2014. 11 years of data show the weak spot has expanded by an area nearly half the size of continental Europe. The minimum field strength inside it dropped from 22,430 nanotesla to 22,094 nanotesla. And since 2020, it's splitting into two cells. The one southwest of Africa is weakening 3 times faster than the one near South America. The cause is deep. 3,000 kilometers beneath your feet, at the boundary between Earth's liquid outer core and the rocky mantle, magnetic field lines are doing something they shouldn't. Instead of emerging outward like they do everywhere else in the southern hemisphere, they're looping back into the core, reversed. And that reversed region is linked to a continent-sized blob of super hot material at the core boundary that scientists call the African Large Low Shear Velocity Province. It's as mysterious as it sounds. Meanwhile, the North Magnetic Pole is migrating towards Siberia. The strong field region over Canada has shrunk by an area roughly the size of India, while the one over Siberia has grown by an area the size of Greenland. You feel none of this. But the satellites above you feel it. The ISS has extra shielding on the side that faces the anomaly. Astronauts passing through it report seeing flashes of light, cosmic rays actually hitting their retinas. The Hubble Space Telescope can't take observations when it passes over this region. Now here's where I have to be honest with you. Everything I just described, the expansion, the weakening, the splitting into two cells, that's all measured, confirmed data. But some people hear this and jump to the next question. Is Earth's magnetic field about to flip entirely? Poles reversing, north becomes south. That part is speculative. It's happened hundreds of times in Earth's history, about every 200,000 years on average, and the last one was 780,000 years ago. But a 2022 study that mapped 9,000 years of magnetic history found these kinds of anomalies come and go without triggering reversals. The lead researcher predicted this one will probably disappear within 300 years. Even if the field did weaken dramatically, it wouldn't be an extinction event. Experiments simulating a 100-fold increase in cosmic rays found only about 30% maximum ozone depletion. The atmosphere picks up most of the slack, so the shield has a hole in it. The hole is growing, but the house behind the shield is tougher than you think. Still, it's growing. Number 3, the last words of Voyager. Right now, 16 billion miles from where you're sitting, a spacecraft the size of a small car is whispering into the dark. The signal it sends is so weak it arrives at Earth with a power of 10 to the negative 16th watts. That is 20 billion times weaker than the energy needed to run a digital watch. And we can still hear it. Voyager 1 launched in September 1977 with 470 watts of electrical power generated by the heat of decaying plutonium. Every year it loses about 4 watts. And every year, engineers have to decide which instrument to kill next. October 2024, Voyager 2's plasma science instrument shut down. February 2025, Voyager 1's cosmic ray subsystem, the very instrument that confirmed it had crossed into interstellar space in 2012, shut down. March 2025, Voyager 2's low-energy charge particle instrument gone. 2026, Voyager 2's cosmic ray subsystem is scheduled to go next, 3 instruments left on each spacecraft. The goal is to keep at least one running into the 2030s. After that, maybe engineering data, a heartbeat until around 2036. Then silence. In November 2023, Voyager 1 started sending garbled nonsense. Still receiving commands, still operating, but the data coming back was unreadable. For 5 months, engineers worked the problem from 15 billion miles away. Every command took 22.5 hours to arrive. Every response took 22.5 hours to come back. 45-hour feedback loops over and over for 5 months. The cause was a single failed memory chip. The fix was relocating code to a different part of the computer's memory. It worked. Then, there's this detail that keeps me up at night. Deep Space Station 43 in Canberra, Australia, is the only antenna on Earth that can send commands to both Voyagers. The only one. And it went offline for upgrades from May 2025 to February 2026. There were limited windows, but for most of that stretch, if something went wrong, no one could do anything. In November 2026, Voyager 1 will reach 1 light day from Earth. A command sent at that point takes 24 hours to arrive, and another 24 for the response. the first human-made object to reach that distance. The team working on this mission includes NASA retirees in their 80s who understand subsystems nobody else alive remembers, working alongside engineers so young their parents weren't born when the probes launched. And somewhere on each spacecraft attached to the side there's a golden record. Copper, plated in gold, etched with sounds and images of Earth, music, greetings in 55 languages. The sound of a human heartbeat. That record will outlast the sun. One day, the last instrument will shut down. The last watt will drain and Voyager will go quiet, still moving, still carrying that record, for billions of years through the empty space between stars. The longest goodbye in human history, and every day between now and then, it gets a little quieter. Number 2. The supernova you could read a book by. Look up at Orion, the bright reddish star on the shoulder. That's Betelgeuse. It's about 640 light years away, 15 to 20 times the mass of the Sun, and roughly 1,000 times its diameter. If you dropped it into our solar system, its surface would reach past the orbit of Mars. It's dying. Betelgeuse has burned through its hydrogen. It's fusing heavier elements now, working its way down the periodic table. Carbon, neon, oxygen. Each stage takes less time than the last. When it reaches silicon, the final stage, that lasts days, maybe weeks. Then the core collapses and the star explodes. In 2019, it did something weird. Dropped to 40% of its normal brightness over a few months. The Great Dimming. The internet lost its mind. People thought it was about to blow. Turned out it had just coughed up a blob of material that cooled into a dust cloud and blocked our view. Not dying, just sneezing. Then, in July 2025, astronomers confirmed something long suspected. Betelgeuse has a companion star. A small hot blue-white star called Sawarha, about 1.5 times the Sun's mass, orbiting so close to Betelgeuse, it's actually inside the giant's atmosphere. It's been there the whole time, hidden in the glare. Sawarha explains why Betelgeuse's brightness wobbles on a 6-year cycle, and why the star rotates faster than it should. The companion is spinning it up. One astronomer said Betelgeuse and its buddy will hug eternally. They'll merge within about 10,000 years. Does any of this change when the supernova happens? Not really. The best estimate is still any time in the next 100,000 years. There's roughly a 1 in 4,000 chance it's already happened and the light just hasn't reached us yet. When it does happen, here's the sequence. First, millions of neutrinos flood every detector on Earth in a 10 to 15 second burst. For comparison, a supernova in 1987 from 168,000 light years away produced about 20 neutrino detections across 3 small detectors. Betelgeuse, at 640 light years, would be about 70,000 times stronger. That's your warning. You get a few hours. Then the breakout flash arrives, and the sky changes. Betelgeuse goes from a normal, bright star to nearly as bright as the full moon, visible during the day. A tiny, searing pinpoint of light. Not a soft glow like the moon. A needle. It would be uncomfortable to stare at. You could read a book by its light at midnight. And it lasts months before fading. Is it dangerous? No. At 640 light years, the inverse square law does all the work. No significant radiation increase, no ozone damage. Just the most spectacular light show any human has ever seen. The last time a supernova was visible to the naked eye in our galaxy was 1604. Over 420 years ago. One dying star, briefly outshining an entire galaxy of 100 billion stars. We don't get to pick when. But we're in the audience. And the show will happen. Number 1. The collision that already started. Look up on a clear dark night and find a faint smudge of light near the constellation Andromeda. That smudge is a galaxy. 2.5 million light years away. 1 trillion stars. About twice the size of the Milky Way. It's the most distant thing you can see with your naked eyes. And it's coming right at us. 110 kilometers per second. Kilometers. 250,000 miles per hour. Fast enough to reach the moon in about an hour. In 2012, astronomers used the Hubble Space Telescope to measure Andromeda's lateral motion precisely enough to confirm what everyone suspected. It's not going to miss. The Milky Way and Andromeda are on a collision course. But then in 2025, a new study used better data from the Gaia spacecraft and ran 100,000 simulations with 22 different variables. The result was more complicated. A head-on collision is only about 50% likely within the next 10 billion years. And when you factor in the gravitational pull of the Large Magellanic Cloud and the Triangulum Galaxy, the chance of a direct hit in the next 4 to 5 billion years drops to just 2%. So maybe not a head-on crash, maybe more of a long, slow gravitational dance. But here's the thing, it's already started. In 2020, astronomers mapped Andromeda's gaseous halo, the vast envelope of diffuse gas surrounding the galaxy. It extends so far that it's already touching the Milky Way's halo. If you could see it with your naked eye, it would be 3 times the size of the Big Dipper, the outermost edges of 2 galaxies already mingling, and even if they do collide head-on, individual stars almost certainly won't hit each other. Stars are absurdly far apart relative to their size. If the sun were a ping pong ball, the nearest star would be a pea 680 miles away. A trillion stars meeting 300 billion, and the chance of any 2 actually colliding is essentially 0. What would change is the sky. Over billions of years, Andromeda would grow larger and brighter until it fills the view, distorting the familiar Milky Way band with tidal forces. The sky would blaze with new star formation. Eventually, 2 galactic cores would hang in the night like bright lobes, and then, about 7 billion years from now, they'd merge into a single giant elliptical galaxy. Astronomers already named it Milkomeda. The 2 supermassive black holes at each galaxy's center would spiral toward each other, radiating gravitational waves, and merge in about 17 million years after the galaxies combine. But you'll never see any of that. None of us will. The sun's increasing brightness will boil Earth's oceans in roughly 1 billion years. Long before any galactic merger becomes visible, this planet will already be lifeless. So why does it matter? Because right now, tonight, that faint smudge in Andromeda is the most distant thing your eyes can reach. And it's not just sitting there. It's falling toward you, and you're falling toward it. And the space between you is shrinking every second you breathe. The universe doesn't wait for you to be ready. Some of these events are happening right now. One will happen on a Friday the 13th, and one of them, the one involving a dying spacecraft whispering from 16 billion miles away, is a countdown you can follow in real time. Because every day, it gets a little quieter,